Okay, so you know how to calculate molar mass. What can we do with it? Well, it turns out this is really important. We're going to use molar mass to convert between grams and moles. That is, given grams, that is, given grams, how many moles do you have? Or the opposite, given moles, how many grams do you have, right? This is very important because it's important because we can measure easily grams with a balance, but it's moles that are the actors, right? It's the moles that match up with other moles of other compounds to do reactions, okay? So how are we going to do it? Well, we're going to take our molar mass and we're going to make conversion factors, right? So we've done conversion factors a couple times now. Conversion factors are just ratios, and they're written as molar masses in this case, right? So we're going to relate grams and moles of an element or compound. For example, we'll use methane here. The molar mass of methane is 16.05 grams per mole, right? Well, what kind of conversion factors we can make? Well, we can say either 16.05 grams per mole or 1 mole per 16.05 grams, right? So these are two conversion factors we can make. We've done this a good bit in the past, right? Using equalities to make conversion factors where one goes on the top and one goes on the bottom. Okay, so let's do it. Let's use an example here. A box of table salt, sodium chloride, contains 737 grams of sodium chloride. You know what's coming, right? If I give you that, and I give you that, the question is going to be how many moles, right? This is super common, so let's get used to it. A box of table salt has 737 grams of sodium chloride. How many moles of sodium chloride are in the box? All right. So the way we're going to do it is here. We're going to say we need moles, right? And we're given grams. And so let's have a conversion factor here, right? Where grams goes on the bottom and moles goes on the top, right? So that way, moles will be our answer and grams will cross off. Okay, so this is great. For sodium chloride, we got to look up the molar mass of sodium chloride. And the molar mass of sodium chloride, let's come here. Oh, you know what? I'm cheating you. Let's do it with a periodic table. Periodic table. Let's calculate it, right? So let's just choose a periodic table here. And we'll go here. I think this is mouse over. It's sodium chloride, right? So sodium. No, that's not good. Nice idea, but let's come here. Sodium. Is 22.99, right? Sodium is 22.99. Right? 22.99. And chloride is 35.446. 35.446, right? So let's go 22.99 plus 35.44. 35.446 is equal to 58.436. 58.436. 58.436 grams per mole, right? So it's going to be 58.436 grams per 1 mole, right? And we were given 737 grams of it, right? So it looks like it's going to be, the answer is going to be 737 divided by 58.436 is equal to, and moles was left, right? That's what was left here. So how many moles is that? 737 divided by 58.436 comes out to be 12.612. 12.612, and I was only given 3 sig figs here, right? There's 3 sig figs here, and this number went out to that place, so this had 4 sig figs. So 3 divided by 4 sig figs is going to give me 3 sig figs. So I'm going to report this as 12.6 moles. Okay, and there's your answer, 12.6 moles of sodium chloride. All right, so let's finish this conversation out with a learning check. Pause the video and do the work on your paper, and then come back on and compare your work to mine. Okay, so I'm going to suppose that you paused it, and I'm going to work this problem. Okay, so how many moles of water are in a sample? So I need moles, right? And I'm given grams, right? There's my grams. And I'm asked for moles. Okay, so let's set up a conversion factor. Use the picket fence method. I realize I'm going back and forth on you there. Moles per gram. Looks like grams are going to be on the bottom. Okay, so let's find the molar mass of water first of all. The molar mass of water is, I still have this periodic table up. It's 2 times hydrogen, 1.0078. Okay. 2 times hydrogen plus 1 times oxygen is equal to 2 times 1.0078 plus oxygen, which is 15.999, right, is equal to 18 point something, right? 2 times 1.0078 plus 15.999 is equal to 18.0146. 18.0146, and since this only goes out to the thousands place, right, we can only go to the thousands place right here, so this number actually has 5 sig figs in it, right? So we'll put 18.0146. I'm going to put a 5 here because it looks like it has 6, right, per 1 mole. That's exact. And this is 59.8 grams. This has 3 sig figs. So I can only report my answer to 3 sig figs. 59.8 divided by 18.0146 is equal to 3.3195. 3.3195. And I can only report the 3 sig figs, so that's going to be my last digit. This is going to be reported as 3.32 moles. All right, so there we have it. Converting between mass and moles using molar mass.